Good afternoon. This is the tag team presentation for week 9, which is over hand tools and power tools. So jumping right in, we'll start with hammers. Hammers are meant to deliver impact to an object. There are 3 different types: claw, ball peen, and soft hammer. Claw hammers have 2 purposes: pounding and extracting nails from wood. Ball peen hammers are used to shape sheet metal. They have 2 sides, but the rounded side is most often used, and soft hammers are used to nudge objects around or to create closure. They typically have steel heads and wooden handles and are commonly found in machine shops. Screwdrivers are tools used to turn screws. Some common types include flatheads, Phillips heads, torque heads, and Allen heads, all of which correspond to different types of screws and have different notches at the tops of those screwdrivers. And lastly, with wrenches, they are tools used to provide grip and mechanical advantages while applying torque to turn an object. Some different types include open-end, combination, Allen, spanner wrenches, and adjustable wrenches, all of which have different variations and different sizes and are used to typically tighten nuts and bolts.
So some other hand tools are pliers, which are basically designed to properly hold parts and materials gently and firmly. Some common pliers are combination pliers, tongue and groove pliers, like the one on the top left picture, which can change the size of its clamp with a button, and it is very good for plumbing. Other pliers are locking pliers and needle nose pliers. Then we have punches, which are metal rods with sharp ends designed to be struck by a hammer. The center punch, like the top right, has a mechanism that allows it to be hammered in deep enough. And then we have transfer, letter, and pin punches. For files, like the one at the bottom left, they can cut down small, concise amounts from materials like wood and metals, and they're named after their shape. Files only cut when they're pushed. There's 2 processes of filing. One is through filing, which you push forward vertically. The other is draw filing, which you hold sideways like a bike handle. And then we have the hacksaw, which can cut through most metals very well. And when the blade is set in a groove, the saw can fully move.
Up next is power tools. Pneumatic tools are generally driven by either compressed air or carbon dioxide. They're safer to run than their electrical counterparts because there are no risks of electrocution or short circuiting. Some examples include jackhammers and pneumatic hammers. When we move on to angle grinders and sanders, both of these tools use abrasion to do their job, but angle grinders are used to cut or polish metal, while sanders are used to smoothen wooden surfaces with sandpaper of varying grit sizes. With a bandsaw, it's basically a power saw with a very long and continuous band of toothed metal. It's used primarily in woodworking, lumbering, and metalworking. Then we move on to drills. These are used to make holes in materials. Some types of drills include hammer drills and drill presses. Twist drill bits are the most common drill bits that are used, and they're classified based on the length of on their length. The jobber series has the standard length bits. The stub series has the short ones, and the long and extra long series have long and extra long bits respectively. When it comes to standardizing the diameter or the size of a drill bit, there are 2 systems, a metric and standard. Under the standard system, there are 3 size classifications. Fractional, which goes from 1/64th of an inch to 1 inch in steps of 1/64. Number drills, which go from number 80, which is the smallest, to number 1, which is the largest. And letter drills, they pick up from where the number drills left off. Now, when we actually drill a hole, we do not use the actual drill that we use directly. To pinpoint the location of the hole accurately, a smaller drill, like a spot or a center drill, is used to create a dimple in the workpiece. and these drills are very rigid. So the positioning of the hole will be accurate. Now, some points of caution that have to be noted. With the drill press, it's always advised to use work holding tools to clamp the workpiece in place and not use your own hand. With drill bits, they should be clamped only at the shank and not the body. The body consists of the flutes of the drill bit. With twist drill bits, it's always advised to clear up any residual materials that are left after drilling the hole, so that the residual material does not impact the bit.
So I'll be talking about some post-drilling tools and processes. So reamers are tools that are used to enlarge the size of previously formed holes by a small amount with a large accuracy. They give a good internal finish and they get the job done with minimal wastage. Countersinking enlarges the top portion of an existing hole to a cone-shaped opening, and out of all the angles given, 82 degrees and 90 degrees are the most common, and it's performed after drilling to provide space for the head of a fastener. Then we have counterboring, which enlarges the top portion of an existing hole to a specified depth, and it has a pilot on its end to guide it straight through a hole and create a flat bottom cavity. Next, we have spot facing, which is the operation of smoothing and squaring the surface around and at the end of a hole so that we get like a smooth level end for a nut. And it's generally done on angled surfaces or castings. Next, we have taps and dies, and this is basically creating threads to enable screwing. So taps create threads internally and dies create threads externally. And now how do we tap a hole? So prior to drilling the hole that you'll eventually tap, you need to determine the size based on the bolt that you're going to use, and you can usually determine this by referring to a technical chart or manual. And you also need to drill the hole to the correct depth and the correct size, which is a really, really important step. And you do have to remember that your hole will be smaller than the diameter of the bolt because the tap threads usually increase the diameter. You hold the tap in a tap wrench, and it's recommended to use a lubricant of some sort to make tapping easier. It makes the cut smoother, cleans out chips, and keeps the drill and the stock from overheating. To begin tapping, we hold the tap wrench perpendicular to the hole and move it clockwise until we feel some resistance in the threads. And then for every clockwise rotation, we go a little fraction anti-clockwise, and this helps us chip the area so we can provide space for further cutting. And we have to remember that taps are very brittle, so we must not let any chips accumulate because it can break the tap. And lastly, it's important to clean out the chips from the tap and the material, remove the lubricant, and test it with your required bolt.
And last, we'll end off with a piece of novel information or a novel application, and that's V-blocks. This wasn't directly addressed in the lecture, but V-blocks are tools used to hold round metal rods and pipes. This work-holding device is employed when performing drilling or milling operations. They encompass a cast iron block that contains a 90-degree channel, which is rotated at a 45-degree angle from the sides of that block, of that cast. A small groove is cut in the bottom of that V, which is formed by the angle. And there are many different variations, but all V-blocks possess a downward clamping force, which is directed on the top of the part being drilled or milled. And that concludes our presentation for this tag team week 9. We hope you enjoyed, and we hope it was informative.
Thank you very much, guys. I would make a comment that you guys went a bit longer than the time intended, but otherwise the information was good and technically correct and clearly presented, so that was really good to see. I don't think I really have any questions. I might suggest that it did come across a little bit of a catalogue-y way sometimes. I would have liked a bit more information like we got towards the end on how the drills are used as opposed to the kinds of things you're looking at, or why you might choose one wrench over another wrench or something like that, which was also in the lecture provided by David. Have you got any comments you'd like to add, David?
One brief one is that some of the presenters, and I didn't catch the very first presenter, presented everything as a suggestion. There are some things that are for safety or for the performance of the tool are actually requirements. So like free holding something that's being drilled is just not allowed because it could get ripped out of your hand and rip your hand in the process. So it's not recommended that you clamp it down. It's required that you clamp it down. Stuff like that. But that's more of a, it's a presentation default, whereas I understand everyone just wants to play it safe and not make an absolute declaration if they're unsure. So,
well,
aside from that, very nice job.
Yeah, I was going to say, as a British origin person myself, actually, we often use please or you should instead of you must, just as a politeness thing, which can be a real problem, as David is pointing out here, that politeness never should take over from the important safety requirements, and the things like taps will just break if you get it wrong, and that will ruin your workpiece and ruin the tap. So, it is important.
I was just going to say, otherwise, excellent.
Yeah.